This is the episode that makes you sound like you've actually run Kafka in production. We're covering the advanced features, exactly once semantics, log compaction, Kafka Streams, the Schema Registry, and Kafka Connect. These are the features interviewers use to separate the people who read a blog post from the people who've shipped real systems. Let's earn it. We'll start with the one that gets asked about the most, exactly once semantics, sometimes just called EOS. Here's the problem it solves. A consumer reads a message, updates a database, and then crashes before it commits its offset. On restart, it rereads the same message and updates the database again. Double update. Bad. Kafka's answer is transactions. A Kafka transaction lets you do two things atomically, as one all-or-nothing unit. Write your output messages to topics and commit your consumer offsets. Either both happen or neither does. So you begin a transaction, send your output events, send your consumed offsets into that same transaction, and commit. If anything fails, you abort, and it's as if nothing happened. On the consuming side, you set the isolation level to read committed, which means consumers skip over any messages from transactions that were aborted or are still in flight. They only see committed data. The full recipe is 3 settings. Enable idempotence for deduplication within the producer, a transactional ID for atomic writes across partitions, and isolation level read committed on your consumers. Together, that's exactly once. But, and this is the crucial caveat, it's exactly once within Kafka, topic to topic. The moment you're writing to an external database, this doesn't cover you, and you need the outbox pattern, which we'll dedicate a whole episode to later. Next, log compaction. Normally Kafka deletes old messages by time. Compaction is a different retention policy. Instead of deleting by age, it keeps only the latest value for each key and throws away the older ones. Picture a stream of balance updates for 2 users. User 1 goes to 100, user 2 to 500, user 1 updates to 150, then to 200. After compaction, Kafka keeps only user 2 at 500 and user 1 at 200, the latest for each. What's that good for? Current state snapshots, account balances, inventory counts, configuration per key. Because a brand new consumer reading from the very beginning of a compacted topic gets a complete snapshot of the current state of everything. Oh, and if you want to delete a key entirely, you write a message with a null value. That's called a tombstone, and compaction removes the key. Third, Kafka Streams. This is a Java library for stream processing that runs inside your own application. No separate cluster to operate. It gives you 2 core abstractions. A stream, which is an unbounded flow of events, and a table, which is the latest value per key, like a live materialized view. And the beautiful part, you can join a stream against a table locally with no network call because the data is co-located with your processor. You can do windowed aggregations like counting events per key over 5-minute windows using local state. We'll go much deeper on stream processing in its own episode. For now, just know Kafka Streams is the in-app way to do it. Fourth, the Schema Registry. Your messages are contracts between teams, and this is what enforces them. The registry stores your schemas in formats like Avro or Protobuf, and the producer embeds a little schema ID in every message. The consumer reads that ID and fetches the matching schema to decode the message. And critically, it enforces compatibility rules at publish time. Add an optional field? That's backward compatible, allowed. Rename a field or change its type? That's a breaking change, rejected on the spot. This is what lets one team deploy a new producer at any hour without silently breaking every consumer that hasn't updated yet. And finally, Kafka Connect. This is how you get data in and out of Kafka without writing producer or consumer code at all. Source connectors pull data from external systems into Kafka. Sync connectors push data from Kafka out to external systems. Two examples you'll hear about constantly. Debezium, a source connector that reads a database's write-ahead log and turns every row change into a Kafka event. That's change data capture, and it's the backbone of the outbox pattern. And the storage sync connector, which archives every event to cheap, immutable object storage for compliance or analytics. So that's the Power Toolkit, exactly once for atomic pipelines, compaction for snapshots, streams for in-app processing, the Schema Registry for safe evolution, and Connect for plumbing. You now know Kafka better than most people who list it on their resume. Next episode, we step back and answer the big practical question. Given all these brokers, which one should you actually use? See you there.